Okay, so as I mentioned, I was going to make videos specifically on fractions, then decimals, then percentages, and we're going to start with everyone's favourite topic in the world, fractions. I say that in a sarcastic way because a lot of people really don't like fractions. And so I'm going to do my best to help as much as possible. So here's all the things we need to know about how to work with fractions. What is a fraction? How to work out a fraction of an amount. How to order them, how to compare them, which are two sides of the same coin, which is why they're put together. How to add or subtract fractions. How to multiply and divide, or at least recognize what we mean by multiplying and dividing fractions. Using improper fractions and what that means. And then using mixed numbers, and these bottom two are also two sides of the same coin. So we could think about it, these two are linked together, these two are linked together, and both these sections are part of the same thing. Both of these sections use similar methods as well. But yes, that's where we're going to start. Okay, so what is a fraction? Well, we know if we take the example 1/2, 1 out of 2, we have the maths words, of course, which are numerator and denominator, which we need to recognize when we see them. But what does a numerator and a denominator actually mean? Well, what we've got is our numerator is the amount of equal parts we have. And that's important. The word equal is very important. So I'm going to underline equal because they have to be the same size as each other. Otherwise, that's not a fraction. So if we have a denominator, it's the amount of equal parts that there are. So in the example of 1 out of 2, I'm going to move this a little bit so we can make it a bit smaller, and then you can see it hopefully on one line. I'll move that line that says equal. Okay, so in the case of our 1 out of 2, there are 2 equal parts, which is why it's at the bottom. If we imagine a pie that's sliced directly in half, we have 2 equal parts, that's how many exist, but we have 1 part that we actually have, and so we have 1 out of 2, or 1/2. And so that's what a fraction actually is. This isn't level 2 stuff, but it's nice to know what we're actually talking about, so that when we look at fractions, we can sort of think about what they're actually telling us. So let's start with a fraction of an amount. We have a fraction of something. 3/4 of 500 as an example. So here's what we're going to do. The method for this is always divide by the bottom of the fraction, multiply by the top of the fraction. And we're going to do it like that. As we know from BODMAS or BIDMAS, the order in which we do divide or multiply doesn't matter. So just pick one that you like the most. If you want to divide first or multiply first, sometimes depending on the number, it might be easier to do one or the other. But you can always just pick one and then do the other one, and you will be okay as long as you're always dividing by the bottom and timesing by the top. And so let's take our 500, and what we're going to do is we're going to start by dividing it by the bottom number, which is 4. And so this is all without a calculator for now. You could be expected to do this without a calculator or with one, so let's take our 500 into 4. 4 into 5 goes 1 time and has a remainder of 1. 4's into 10 goes 2 times with a remainder of 2. 4's into 20 goes 5 times, and so we have 125. Then if we multiply that by the top number, 125 times 3 is going to be equal to 375. And so our answer for this question is 375. That's a fairly nice number to start with. Let's pick a number that's not so nice. Here we go. What is 3/8? And sometimes they could be written in words, so we have to recognize that this is the same as this, 3/8. You could have halves, thirds, quarters, fifths, sixths, sevenths, and so on. So recognizing what this language actually means is important to answer the question. So if they say, what is 3/8 of 736? Well, we do the same thing again. Whatever you want to do first, it's up to you. I'm going to do the dividing again, because this is what I'm used to doing. But you could times it by 3 first if you wanted to. So let's take our 736 and divide it by 8. 8 into 7 doesn't go. 8 into 73 is 9 times, and with a remainder of 1, because 8 9s are 72, with a remainder of 1. And 8 into 16 goes twice, so our answer is 92. We're going to multiply that by 3, and that's going to give us an answer of 276 as our answer for that. our times tables are really, really useful for finding fractions or percentages of something, because it will help us save time when we're going through this process of trying to figure out what will fit into what. If we're not sure, say we get to 8 out of 73 and I don't know how many, well, we could write our 8s down. We could say 8, then 16, then 24, and so on and so on and so on, until we got to 72. And then we could, as we count down, we'd say, oh, that's 1, and then 2, and then 3, and this would be 9 as we got down to it, and that would be our answer, and that goes up there. It takes longer, but as long as you end up with the right answer, it doesn't matter how long it takes you to get there within some sort of reasonable limit, because being right is more important than rushing and getting it wrong. On the flip side, it is important to keep a track of time in your mind so that you don't run out of time in the exam, because nobody wants that. So that's how I'm going to work out this question. Here we go, here's a nice one for you. Work out 5/9 of 810. So have a think about what that word means. What fraction are we looking for? Have a go. I'll be back in a few seconds to go through it with you. Okay, so I've been kind to you and I've given you something that will directly go into nines. If you know that 9 nines are 81, then our bottom number, we're going to have 90 when we do 810 divided by 9 equals 90. And then we're going to multiply that by 5, and we're going to end up with 450 as our answer, because 9 5s are 45, and put the 0 on top. So hopefully you got the answer of 450 for this question. Very good job if you managed to get that. If you didn't, go back again and have a look at how we work out a fraction of something. It is by dividing by the bottom and then timesing by the top. You should have also written down somewhere that this was the same as this, to show that you understood that 5/9 is 5 out of 9. Okay, moving on to an exam style question. It says 3 friends share a lottery win of £1,710. Priya gets 3/5 of the money, Raj gets 2/9 of the money, and Adam gets the rest of the money. How much does each person get? So there's a bit of multifaceted stuff in here. We have to do 2 different fractions and then work out the remainder basically, and then that's how much Adam gets. So have a go at this. Same principles as always. Take your time. It's probably 2 or 3 minutes on this question. And I'll be back in just a second. Okay, so let's start with whichever one we want to. I'm going to start with Priya first. So I'm going to make that P. Okay, so let's say we have 1,710, which we do. I'm going to divide that by 5. And if I do that, we're going to have our bus stop method, because I don't know it off the top of my head. And we're going to go 5s into 1 goes no times. 5s into 17 goes 3 times with a remainder of 2. 5s into 21 goes 4 times with a remainder of 1. And 5 goes into 10 2 times, so it's 342. Then we take our 3 and we multiply this answer by 3. And what we're going to end up with is 900, 1,020, 1,026 as our answer for this question here. And so Priya got 1,026. So we know already that she's going to get the most of the money, because that's already more than half and there's still 2 people to split it into. So Raj then, he gets 2/9 of the money. So we're going to do the same thing again, 1,710, but this time divided by 9 equals. So we're going to put my 9 here. I'm going to put my 1,710 here. 9s into 1 doesn't go. 9s into 17 goes 1 time with a remainder of 8. And 9s into 81 goes 9 times, and the 0's here, so the 0 goes here. So we've got 190 times by 2 is 380. Okay, and then it says that Adam gets the rest of the money. So we're going to add these 2 things together and work out what's left. So if we add them up first, 6 and 0 is 6, 2 and 8 is 10, 3 and 1 is 4, and 1 plus nothing is 1. So we have 1,406. Finally, if I do 1,710 minus 1,406, what we're going to end up with is 0 take away 6 we can't do, so we borrow 1 from here. 10 take away 6 is 4, 0 take away 0 is 0, 7 take away 4 is 3, and 1 take away 1 is nothing, so we have 304. And so that's what is Adam's score. And so Adam gets 304, Priya gets 1026, and Raj gets 380. Very good job if you managed to get that correct. If not, have a go through again, have a look at how we managed to get to those answers, and hopefully it'll start to make sense the more you do it. Okay, and now on to ordering fractions. Well, what do we mean by this? To order a fraction, we're going to put them in order, surprising nobody. But to do that, we need to make the bottom number, or the denominator, the same. And this will be the same for quite a few of our techniques we're going to be doing. So adding and subtracting, we do this. Comparing and ordering, we do this. And so we have to make the bottom number the same. And let me show you an example of how we're going to make the bottom numbers the same. Let's take something not too complicated. Let's say it's 1/2 and we have 3/4. And I want to order them in terms of size. And let's say I want to make them biggest to smallest, okay? How am I going to compare whether this is bigger or this is bigger without turning them into a decimal or a percentage, which some people might be inclined to do? We're not allowed to do that. We have to keep them in terms of fractions. So how are we going to do that? Well, we want to make the bottom number the same. This is where our knowledge of times tables really comes in handy, because we can work out, for example, that 2 will go into 4, because 4 is in the 2 times table. So how many 2's in 4? Well, to get from 2 to 4, I'm going to multiply by 2. 2 lots of 2. What I do then is I do the same to the top of this number here. And what I'm going to get is 1 times by 2 is 2. And so our fraction is 2 out of 4 compared to, this is a versus sign, compared to 3 out of 4. So if I want to put them in order of size, with this one being the biggest, this is going to be number 1 and this is going to be number 2. And so our answer, if I move this to the side, move this over here, sorry, there we go. Our answer would be, order of size, it would be 3/4 and then 1/2, just as an example of how we do the problem. So doing another example question, place these fractions in order of size from smallest to biggest. Okay, so same sort of idea, except we've been given more fractions. So once again, our knowledge of times tables is really going to come in handy. If we're not sure, I'm going to type this because it will save me some time and my handwriting's not so good. I'm going to decide what number appears in all of these times tables. So starting with the 2 times table, 2, 4, 6, 8, and etc. And I'll keep going like so. Okay, that's the 2 times tables. The 4 times tables now, 4, 8, 12, 16, 20, 24, 28, 32, so on. Then I could do the 6 times table, 6, then 12, then 18, then 24, then 30, then 36, then 42, and so on. And then finally the 8s, so I can do 8, then 16, then 24, then 32, then 40, then 48, and so on. Knowledge of times tables really, really useful or important. And if not, at least you can always write them down like I'm doing now to get an answer. So what we're looking for then is the first number that appears in every single one of these lists of numbers that I've just made. So as I go down the list, let's think about it. Okay, well, the number 12 appears in these 3, but doesn't appear here, so that's no good. But the number 24 here, then 24 here, then 24 here, and 24 here, is going to be my answer. And as a little shortcut for you, we know that our answer is going to be fairly early on, you would think, in our biggest numbers times table. So we can see that this is only the 3rd number in here, whereas it's way down the list in here. So don't start looking in the 2s, start looking in the 8s, and then work your way backwards to see if it will fit in the list. So we know actually that all of our numbers then, when we compare them, are going to be, or ordering them, sorry, are going to be over 24. So we know that we're going to have 4 fractions out of 24. And this is what we do. Underneath, I would write them all as out of 24. Okay? Now then, how do I work out how many lots of everything do I have to go up to get to 24? Well, it's in my times tables. I've just worked them out. 3 8s, 1, 2, 3 is 24. And so 3 times 7, because we do the same to both sides, 3 times 7 is 21. So it's 21 out of 24. 6, 1, 2, 3, 4 6s is 24. So 4 5s is 20. Okay? Hopefully you're following along with what I'm doing. If not, that's okay. Go back to the video, have a go again. It will click, you look at it and go, oh, right, is that all it is? Going in the twos, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 times 12 is 12. Also, this is a half, so you know that 12 is half of 24. But that's fine. If you're not sure, just have a look in the times tables. And then finally 4, 1, 2, 3, 4, 5, 6. 6 threes are 18. And so what we've got is all of our numbers out of 24. Now, when we actually compare them in terms of size and order them, what we're going to be doing is looking at our top numbers, or our left-hand numbers in this case, and deciding which one's the biggest and which one's the smallest. This is the smallest, that's number 1. Then this is the smallest, so this is number 2. Then this is the smallest, so this is number 3. And finally, this is the smallest, so this is number 4. Similar to ordering fractions, decimals, and percentages, what we do at the end is put them back in order, but in the way that they gave them to us. So in this case, we're going to have a half. Then we're going to have 3 out of 4. Then we're going to have 20 out of 24. And then we're going to have 5 sixths, sorry, beg your pardon. And then we're going to have 7 eighths, like this. So now they're back in the order that they gave them to us in, or the way they look, I guess. And so that's going to be my answer. I use my numbers to help make sure that I put them in the, I know which one I'm talking about. So these two are linked, these two are linked, these two are linked, and these two are linked. So I don't lose track of which one's which is why I go to the trouble of writing them all exactly underneath the previous ones. So that's my answer. A half, 3/4, 5 sixths, and 7 eighths. Which makes sense when you think about it. If you think of our little slices of cake, each time we're doing this, we're getting ever so slightly more cake. Which, who can complain about that? Okay, so, on to the practice question. They say put these fractions in order from largest to smallest. So be careful, I flipped it round on you. From largest to smallest. Have a go. See what you think. I'll be back in just a second to go through it with you. Okay, so, similar to the last problem, we have to find a number that goes into all of these. I also told you that it's probably going to be best to start with the bigger number, so I'll start there. 12, 24, 36, 48, 60, and so on and so on. I noticed straight away that the number 36 is interesting, because 6 sixes are 36, so I know that will work. 9 fours are 36, so I know that will work. And 3 12s is 36, so I know that will work. Therefore, I've only had to do one times table, and I know my answer is going to be 36. So we're going to have 4 fractions out of 36. Now, just so you know, it doesn't have to be the first one that appears. Any number that goes into all 4 will work just fine. It might just take you a little bit longer to work out what the numerators or top numbers should be. So let's say there are 4 9s in 36. So this is going to be 20 out of 36. There are 6 6s in 36. So this is going to be 24 out of 36. There are 12 3s in 36. So 1 12 is 12 out of 36. And then finally, there are 3 12s in 36. So 3 7s are 21 out of 36. Now I can order them, but I want to order them from largest to smallest. So this is number 1, is largest. Then the next largest is this one. Then the next largest is this one. And the next largest is this one. And then finally, as we always do, put them back in the order that they gave them to us in. So 4 out of 6, then 7 out of 12, then 5 out of 9, and then 1 out of 3. And so as we're going down, we're getting smaller and smaller and smaller, and they're in the form that they originally gave us them. I keep saying order, I mean form, the way that they look. Obviously, if you put them back in the order they gave you in, you haven't done anything. The form, the way that they look. Put them back the way that they gave them to you in terms of looks. And there we go. So that would be your answer. Very good job if you managed to get 4 6ths, then 7 12ths, then 5 9ths, then 1/3 as your answer. And if not, don't worry, that's okay. Have a think about it. Go back to the video, go back through. Remember that the key things to remember are we've got to make the bottom number the same somehow. And what will usually be the case in these sorts of questions is that there'll be a number that goes into all of their times tables that we can use to work out the top numbers or numerators. Okay, from here, here's an exam style question. It says, Ramesh, Nicola and Paramjeet are competing in a science contest. Ramesh gets 11 out of 60 of the votes, Nicola gets 2/5 of the votes, and Paramjeet gets 5/12 of the votes. Put the contestants in order from third to first place. So what we've got to work out is We don't even need to know how many votes it is. We're just going to stick with the fractions. That's our clue that we're probably going to have to be comparing the fractions or ordering the fractions in terms of size, and we're going to order the people as our answer. So in this time when I say put them back in the form they've given you in, the form they've given us is the names of the people rather than the fractions. So have a go. See what you think. Have a go, and I'll be back in a few seconds to go through it with you. Okay, so I've been a little bit kind to you here. The number that every number is going to go into is actually 60 itself. And sometimes that will be the case. So we know that Ramesh gets 11 out of 60, and so his answer is going to be 11 out of 60. That stays the same. Then, how many 12s go into 60? I'm going to write R above this so I don't forget. We know now that this is going to be P, and so 5 12ths, how many 12ths in 60? 5. So 5 times 5 is 25, and that's going to be 25 out of 60. Then finally, we have Nicola, and Nicola is going to have 2/5 of the vote. How many 5s in 60? Well, that's 12. 2 12s are 24, and so we're going to have 24 out of 60. Okay? And that's going to be our answer. So now, which one is from third to first? So we're putting third place first, so the smallest, so that's 1, then 2, then 3. And so our final order is Ramesh, Nicola, Paramjeet. The very order that they told us in the question turns out to be the correct order of votes. And that can happen. There's no reason why it can't happen. And that's our working out too. You'd probably write the times tables down somewhere to show that you understood. But in general working, you've made them all out of the same number so that you can compare them. And then you've worked out what you're going to get. If you really want to be sure that you've explained it well, what you would do is underneath here, you'd write times 5, for example. This is times 12. And this is times 1. It stayed the same. So that would be how we got to these answers. 2 times 12, 5 times 5, 11 times 1. Like that. And so very good job if you managed to get Ramesh, Nicola, Paramjeet as your answer. And if not, that's okay. Go back through the video again. Have a look, make sure you understand it. Take it at your own pace, because these things do take time to bed in. And over time, the more you do it, the more you look at it, hopefully the more sense it will start to make. And so that is ordering. Comparing fractions is much the same, really, except usually what you'll get is a comparison between two things. And so instead of saying put them in order, they'll tell you which one's the bigger, which one's the smaller, which one is the largest, which one is the smallest. And so instead of putting them all in order, you just have to work out which one is bigger than the other. And so let's have a look at an example question. They say which is larger, 1/4 or 1/3? And so once again, we have to work out a number that's in both of those times tables. Here's where I'm going to introduce an idea that's going to come in handy when we do adding and subtracting fractions. If we really don't know what number goes into both top and bottom numbers, I mean both fractions, the 4 and the 3, we can multiply them together. And so what we're going to do is we're going to multiply both numbers together. That will give us a surefire answer for what will work in both fractions. 4 times 3 is 12. So what we're going to end up with is 2 fractions out of 12. And in this case, that is actually also the smallest number that goes into both numbers. Once I've got here, how do I get from 4 to 12? Well, 4 times 3 is 12, so 1 times 3 is 3. How do I get from 3 to 12? Well, 3 times 4 is 12, so 1 times 4 is 4. Okay, and so let me, in blue, show you what I did to get here. This is times 3. This is times 4. And so I did the same to both numbers, both times 4 and these both times 3. Okay, and we end up with these answers. Now, which one's bigger? 3 out of 12 or 4 out of 12? Well, at this point, we look at the top numbers and see that 4 is bigger. So our answer is 1/3. Again, putting it back in the way that they gave it to us. 1/3 is our answer. And some people, that confuses them because this smaller number is smaller than this, but it actually means that each slice of our pie, if we cut it into 3, each piece is bigger than the other. And so we've got 4/12. That's our method. it looks a bit messy, but it doesn't matter about how messy it is, as long as you make sense of it. And then when the examiner looks, it's not completely messy, so that they can understand where you got the answer from. And so it's 1/3. So as another practice question, here we go. Which is smaller, 5 out of 12 or 6 out of 13? Have a go. Try and use the method we've just explained. If you're unsure, go back, have a look at the method again, then try and answer the question. I'll be back in just a second to go through it with you. Okay, so the reason why I told you about that method is because we could write the 12 times tables out and the 13 times tables out, but that's going to be a bit of a puzzle to do. It's going to be quite annoying. So what we're going to do is do 12 times 13 instead. So let's do 12 times 13. Well, 12 12s is 144, which is a sum you are expected to remember. And so we can add another 12, and what we'll get is 156. So we're going to end up with two fractions out of 156. Well, how many 12s in 156? Well, it's 13. So 13 times by 5 is 65. Then how many 13s in 156? Well, it's 12. So 6 12s is 72. So what we end up with is 65 and 72. Which one's smaller? Well, it's going to be this one. And so our answer is this one. I try and draw them on the same direction that I've started with so I don't get confused about which one was which. Our answer then is 5 out of 12. And so very good job if you managed to get 5 12ths. Good job if you did that. If you're not sure and you want to go back, have another look at slide 12, which is here, and make sure you understand what we actually did to work out how to compare the two fractions together. Okay, so here's an exam style question for you to work with, where we have to compare which one is the biggest. Katrina wants to work out which vat of water contains the most liquid. All the vats have the same maximum capacity, meaning they can all hold the same amount of liquid. She knows that one vat is 5 12ths full, she knows that the second vat is 11 out of 18ths full, and she knows that the third vat is 4 9ths full. Which vat has the most liquid inside of it? There are lots of ways of working this question out. I'm going to do the way that makes the most sense to me, but try your best to do whatever you think is sensible, and I will see you in just a second. Okay, so what we're going to do in this sort of question is I'm going to actually do a similar thing to ordering my fractions, where I'm going to work out what bottom number goes into each one. In this case, I can work out that 36 once again goes into each one. So how many 12s in 36? Well, it's 3. So our answer here is going to be 15 out of 36. How many 18s go into 36? Well, 2 18s is 36. So 11 times 2 is 22 out of 36. Okay. Next thing we're going to do is how many 9s in 36? 4 4s is 16 and 4 9s is 36. So we're going to have 16 out of 36. Then, which one has the most liquid in? Well, it's going to be this one. So the answer is the second vat, and that's how I'd write my answer. I just put the second vat has the most. Okay, that's one method of working out the answer if we want to order them. If we want to do our comparison method where we work out which ones multiplied by which ones, that's going to be a little bit harder, but it is something we can do. So what we're going to do is we're going to do 2 or 3 different steps. I'm not going to try and do 12 times 18 times 9 because that gets very confusing very fast. So what I'm going to do is compare them separately against each other and see which one wins. So let's start with 12 and 9. I know that 12 tens is 120, so minus 12 from that is 108. So what we've got is 2 fractions out of 108, okay? That's where I'm going to start. Then, how do I get from 12 to 108? I times it by 9. So 5 times by 9 is 45. Okay? How many 9s to 108? Well, 9 times 12 is 108. And so what we're going to end up with is 4 times 12 is 48. Okay? So far, I've worked out that 4 9ths is bigger than 5 12ths. Okay? Now I can compare my bigger one to the next one. And if the next one is bigger still, then I've got an order, because if this one is bigger than that one, and I already know that that one is bigger than that one, then it must be the biggest of all. So let's do 9 and 18. I know that 10 18s is 180, and that's why I've picked the 9, because I know the 10 times tables, so I can work backwards. If 10 18s is 180, then take away 18 is 162. So that's what I've ended up with. 2 fractions out of 162. Now, how do I get from 9 to 162? Well, I times it by 18. So 4 times 18 is 72. Okay? Next, how do I get from 18 to 162? I times it by 9. So 11 times 9 is 99. Now I can see that this one is bigger, so this one is bigger. And I've seen that this is bigger than this, and this was already bigger than that. So this must be the biggest of all. And that's going to be my answer. So once again, the second VAT has the most. Both ways has ended up with the answer. One way might make more sense to you than the other, and just use the way that makes the most sense to you. We don't need to reinvent the wheel. If you find a method that you like, stick with that and keep using that. But that is at least 2 methods of finding the answer. Okay, moving on. Adding and subtracting fractions. This is where all the stuff sort of culminates into one method that we're going to do. So same thing again. Find the same bottom number. Okay, that's step 1. Multiply across diagonally for each fraction. And I'll explain what I actually mean right now. So what is my example question? So I don't do the same again. Okay, let's say we want to do 1/5 add 1/4. Okay, we're going to do a fifth add a quarter. I'm going to move this up a bit so we can actually have some space to work with. Okay, my fifth plus my quarter. I want to know what it's equal to. First things first, times both bottom numbers together. That's where we start with these all the time. So similar to our comparing fractions, we're going to times the bottom numbers together. 5 4s are 20. So I ended up with 2 fractions that I'm going to add up out of 20. Next, with a different colour pen I'll show you, we're going to multiply across diagonally for each fraction. So what I mean by that is we're going to multiply, but we're going to go diagonally. So going across and down like this, that's diagonal. So 1 times 4 is 4. Okay, I start on the top and I work my way diagonally the other way. So 1 times 4 is 4. Use my green pen. 1 times 5 is 5. And I'm using the colours to show you how I got to the answer. What's important is that if I start on the left, I end up on the left. If I start on the right, I end up on the right. That's going to be very useful when we get to subtracting fractions. But for now, let's stick with this. So we've got 2 fractions out of 20. And then once we've got the denominators or the bottom numbers the same, all we do is add the top numbers together. So 4 add my 5 is 9. So my final answer, assuming I can't simplify it, which in this case I can't, is going to be 9 out of 20. And my final answer is 9 out of 20. So let's do another example just to really embed this knowledge in. 2/5 add 4/7. Okay, so we've got a 2/5 add 4 out of 7. First thing we do is multiply the bottoms together. And I would write this and do the same method every time just to show that I'm practicing it and understanding it. 5/7 is 35. So I've got 2 fractions out of 35. Okay, then I use different colours. You can do whatever you want to help you as long as you don't write in a different colour in the exam. But for practice, we can use different colours to show our point. 2 7s is 14. 4 5s is 20. Because we're timesing all the time as we go diagonally down. And timesing again. The world's worst times symbol, but you'll forgive me. 14 add 20 is how much? Well, that's going to be 34 out of 35. So almost a whole amount, but not quite. So our answer is 34 out of 35. And that's my answer. And this is probably as much method as you need to show as well. How I got there, what I did to work out how to get to the answer. So here's a practice question for you to have a go at. What is 9/13 minus 1/4? The only bit of information I'll give you about the difference between taking away and adding, it's exactly the same method as we've just done, except it's really important that if you start on the left, you end on the left, and if you start on the right, you end on the right, and I'll show you why in just a minute. So have a practice, see what you think, and I'll be back in just a second. Okay, so here we are. We've got 9/13 and 1/4. Let's start with this then. So the same method as I always do, 9 out of 13 minus 1 out of 4. Well, 13 times 4 is going to be 52. So we're going to have two fractions out of 52. Okay, so let's start there. And that's going to be equals something out of 52, which we might be able to simplify, but we'll do that later on. Next, we go down from the 9 to the 4, and 9 fours is 36. Then we go from the 1 to the 13, and 1 times 13 is 13. And so what we end up with is 36 minus 13, which is 23 out of 52. 23 is a prime number, and so we can't go any more unless 23 goes into 52, which it doesn't. So our answer is 23 out of 52. Let me show you what happens if you don't do it in the right order. So let's say somehow we've ended up with 13 out of 52 minus 36 out of 52. Okay, what we're going to end up with is minus 23 out of 52, which is not the same answer. This is less than 1 now. And although that can happen, we've got to be sure that our answer is actually the right way round. And usually what will happen is biggest take away smallest, although that's not always the case. This is the left-hand one, so this is the left-hand one. This is the right-hand one, so this is the right-hand one. You've got to respect the order, and it's really important when you take them away from each other that if you start on the left and you go down, your answer is on the left. And if you start on the right and go down, your answer is on the right. Okay, moving on. Here's an exam-style question. Bethany has some counters in a bag. They come in 3 different colours, red, blue and green. She knows that 5/8 of the counters are red and 1/6 of the counters are blue, and she wants to know what fraction of the counters are green. So, have a go. There's lots of different ways of answering this, but this is an addition question in disguise, and a subtraction question as well. So, have a go. See what you think. I'll be with you just a second to go over how I would do it. Okay, so although, like I said, there's lots of ways of doing this, I'm going to do it to work out what isn't green, so I can work out what is green. How am I going to do that? Well, I'm going to add my two fractions together. 5/8 add 1/6. Okay, brilliant. So 8 sixes are 48. Okay, and we know that if we go down like so, 5 times 6 is 30. 1 times 8 is 8. So what we've got so far is 38 out of 48. Okay? That's what isn't green. But if I know what isn't green, I can work out what is green. If we think of all of the counters all together, that's going to be 100%, right? Or all of the counters. As a fraction, 100% is just the number 1. So what we're going to do now is we're going to do 1 minus 38 out of 48. Okay? Next, we're going to say, well, what does 1 mean as a fraction? Well, I could say that means 1 out of 1, or all of it. Do the same thing. So 1 times by 48 is 48. Take away something out of 48. Okay? I'm going to multiply down. So 1 times by 48 is 48. And 38 times 1 is 38. Like so. So how much is left? Well, what we've got is 48 take away 38, which is 10 out of 48. You may have been able to see that already, but I just wanted to show you that we can do this method even to work out what's left by taking away the 38 from 1. So what we've got is 10 out of 48. That, of course, isn't our answer because we can simplify this a little bit more. If we half both of these numbers, because they're both even, our final answer is going to be 5 out of 24. And that's going to be our final answer because we can't simplify this anymore. So, really good job if you managed to get 5 out of 24 as your answer. You could have also done the comparison method or the ordering method. There are lots of different ways of working out the correct answer here. But if we're going to do our adding and subtracting method, this is the way of doing it. And that's our method as well. So hopefully this makes sense. If not, go back through again. Get used to adding and subtracting fractions because this does trip a lot of people up. But with practice, you will get there if you keep at it. Okay, so now a little short thing on multiplying and dividing fractions. It's good to recognise what we're doing here. So multiplying and dividing fractions is actually easier than adding or taking away fractions, as it turns out. And that's because we don't need to make the bottom number the same. We just don't. What we're going to do for multiplying is we're going to do top times top and bottom times bottom. So what I mean by that is if I take my 3/5 and I times it by 4/9, all we're doing is 3 times 4 and 5 times 9. And so in this case, 3 times 4 is 12 and 5 times 9 is 45. So my answer is 12 out of 45. And that's my answer. Of course, we can simplify that a bit if we want. We could divide it by 3 and we'd end up with 4 out of 15. And then we can't simplify it anymore. For now, I'm not too worried about you simplifying it to the simplest form. I'm just showing you how to do the method. If we take our second example and we do a division, same numbers, but divided by instead. Okay, just a little quick cut in here because I made a slight mistake that I want to correct before I push the video. And we change the sign to be times instead of divide. So what this is keep, change, and flip. You can use the acronym K, C, and F to remember what we have to do. We keep the first one the same, we change the sign from divide to times, and we flip the second fraction, which is called the reciprocal. Not that that's that important, but that is the reciprocal of the fraction, means flipping it over. And so what we end up with, if I move this over to the left so we give ourselves some more space, we can now do our timesing thing again, which we like because it's fairly straightforward. We can do 3 times 9, which is 27, and 4 times 5, which is 20. And so we end up with 27 out of 20. Now this number is a top-heavy fraction, but we'll get into what that means in just a second. So here's a practice question for you to try. What is 1/7 divided by 2/5? Remember what we've just talked about? Have a go, and I'll see you in just a second when we go through it. Okay, so we've got our 1/7 divided by 2/5. I know it's a divided by question, so straight away I'm going to change it and then flip the sign like this. So our actual answer is going to be 1/7 times by 5/2. So 1 times 5 is 5, and 7 times 2 is 14. So what we get is the answer 5 out of 14. So very good job if you managed to do that. Remember that the acronym that we need to remember is keep, change, and flip. And that will help you to remember what to do if you see a dividing fractions question. Back to old me. So moving on, we've got an improper fraction. Well, what is an improper fraction? Let's take probably the simplest improper fraction, which is 3 out of 2. Okay? What we've got is a numerator bigger than the denominator. Or, in non-math speak, the top number is bigger than the bottom number. What that means is that we can call this a top-heavy fraction, an improper fraction, and it essentially means that our answer is more than 1. If you think about our pie, or apple pie or whatever, we split it into 2, but someone's gotten 3 pieces. That means they've actually got 1.5 pies. So they've got more than 1. And so here's how we use improper fractions. They can ask you to add, subtract, times, or divide improper fractions. And it's the same idea, except we're going to end up usually with a number bigger than 1. So the top number is going to be bigger than the bottom number. So here's an example question. Do the same thing, it's an adding one. So if we remember what we do with adding, 9 out of 5, add 3 out of 2 equals, well, 5 times 2 is 10. So we end up with something out of 10, add something out of 10, okay? Then what we're going to do is 9 times by 2 is 18, and 3 times by 5 is 15. So our answer we actually ended up with is going to be 33 out of 10. Now they could say convert this into something called a mixed number, but we're going to get into that in just a second. So leave it as a top-heavy fraction for now. Simplify it if you can. In this case, we can't. And so our answer is going to be 33 out of 10 as our answer, or 3.3. And again, if I show you this as an actual sum, 9 divided by 5, add 3 divided by 2 is 3.3, or 33 over 10. Just to show you that, 33 divided by 10 is 3.3. So it's the same answer. Okay, so here's the practice question. What is 11 quarters minus 5 halves? There's lots of ways of doing this, but have a go, whatever method you feel more comfortable with, and see if we can come up with an answer. I'll see you in just a second. Okay, so what we've got is 11 quarters minus 5 halves. Okay, there are an easy way of doing this, but I'm going to do it the subtraction method. So what I'm going to do is I'm find 4 times 2. So 4 times 2 is equal to 8. So we're going to have 2 fractions out of 8. Okay, then I'm going to times down here. I've changed the colours now, but don't worry about it. That's 22 out of 8. And then we're going to do 5 times 4 is 20. Okay, and so what we've ended up with is equal to 2 out of 8, which we know we can simplify to 1 quarter. So our answer is 1 quarter. What you could have also done is you may notice that 2 goes into 4. How many times does it go in? Well, twice as many. So 2 times 5 is 10. So we could do 11 take away 10 is 1 out of 4. That is another way of doing it. But if you just want one method that will always work, we can do it like this. And our final answer would be 1 quarter. So very good job if you managed to get 1 quarter. The reason why I haven't got exam style questions for this is because they'll be the same as the others, except they'll throw in top heavy and mixed numbers as well. And it's just the same principles, but understanding what the numbers actually mean. Okay, so final topic, and this video has been going on long. I was very optimistic when I said all of fractions, decimals, percentages would be done in an hour, more like an hour each, but that's fine. Okay, mixed numbers. What is a mixed number? Well, a mixed number is a way of showing a top heavy fraction as a whole number and a fraction. So if we go back to our 3 out of 2 from before, okay, what we've got then is 1 whole one, because 2 goes into 3 one time, and a half. So it's 1 and a half. So the way we work this out is we say, okay, how many times does the bottom number go into the top number, and how much is left over? So if we take a different number just to show you the idea, let's say we've got 7 quarters, okay? What I do is I say how many 4s go into 7? Well, 1 4 goes into 7, so we got the number 1. What's left over? Well, 1 times 4 is 4, so what's left over is 3, so that goes there. And then what goes on the bottom is the same denominator or bottom number that we had before. So we've got 1 3/4 as an answer. Another one, just to keep practicing this because it's a skill that you need to develop. Let's say we're going to do eighths now. And I'll do a number that's not going to be a number of 1. Let's say we've got 35 out of 8, okay? Well, how many times does 8 go into 35? Well, the answer is 4. 4 eighths are 32. So what's left over is 3. So what we have is 4 and 3/8. These two things equal the same thing. This is top heavy and this is mixed number. So if they say give your answer as a mixed number, what they're looking for is this. And if they say nothing, don't bother about it, you can probably leave it as a top heavy fraction. But usually they want it as a mixed number. So here's an example of a question. Like I said before, they can do adding, subtracting, timesing, and dividing for mixed numbers. First of all, what I'm going to do is I'm going to deal with the whole number bits of the question. 2 and 4. It's an add, so 2 plus 4 is equal to 6. So I'm going to put that to one side now. And I'm going to deal with the fractions on their own. So what I've got is 1/2 add 3/4. Okay? Same as before, we're going to do 2 times 4 is going to be equal to 8. Add another fraction that is equal to 8. Then as I go down diagonally, 1 4 is 4. And 3 2s are 6. So what I've ended up with is how many 8s? Well, I've got 4 plus 6 equals 10. So I've got 10 out of 8. What do I notice? Well, I notice that this is also a top-heavy fraction. So what I've got to do is make this into a mixed number. How many 8s in 10? Well, it's going to be 1. What's left over? 2. So 1 and 2 out of 8, which we could also say, well, 2 out of 8 is a quarter. So I'm going to say that's actually 1 and 1 quarter. And do simplify your mixed numbers. You only simplify the fraction bit. So what I've actually got then is 6 from before, add 1 and a quarter. Well, again, do my whole number bits first. 6 add 1 is 7. And there's only one fraction, so I'm just going to put that on the end. So what we've got is 7 and a quarter. Okay? I'm going to do this with different numbers because I feel like some people get a little bit stuck here. So I'm going to just pick different numbers and do another question with you. So let's say 1 and 4/5 add 2 and 3/7. Okay? Start with our whole number bits first. 1 add 2. 1 add 2 equals 3. Okay, now let's deal with the fraction bit. 4/5 add 3/7. Okay, so same as before. 5/7 is 35. Okay, then 4/7 times 4 times 7 is 28. And 3/5 is 15. Okay, should have written this in red, but it doesn't matter. You'll see what I mean. 20 and 8. There you go. That's how I got there. 28 add 15 is 43. So we end up with 43 out of 35. Okay, now I know that that's a mixed number, so I'm going to move this down over here. How many 35s in 43? Well, there's only going to be 1. 1 times 35 is 35, so what's left over is 8 out of 35. Okay, move that up here. Add them together. We've got whole numbers. 3 add 1 is 4, so we're going to have 4. This is a fraction, but there's only one fraction now, so it's 8 out of 35. Can I simplify that anymore? No, because 8 doesn't go into 35, and one's even and one's odd, so we're stuck as we are. So our answer in this case is 4 and 8/35, so 4 and 8 over 35. So do the whole numbers first, then do the fraction bit, and work it out from there. Okay, now then, what about if it's a takeaway question? Because the example practice question I'm going to get you to do is the same as a takeaway one, so I want you to get really good at these first, before I throw you into the deep end and you think, what are you talking about? So let's say 3 and 4/5 take away 1 and let's say 1 and a quarter, okay? I've changed the numbers around. Again, we're going to start with the whole numbers. So 3 take away 1. Well, 3 take away 1 is 2. So we're going to have a 2 here. Then we can deal with the fraction bit. 4/5 minus 1 quarter. Okay, starting again. 5 4s is 20s. So we're going to have 2 fractions out of 20. Diagonally multiplying across, 4 4s are 16. And 1 5 is 5. Okay, so now we've got 16 take away 5. 16 take away 5 is 11. So we've got 11 out of 20. Okay, we take that and we add it on to our 2. So we've got 2 and 11. How's that ended up red? It helps because you probably clicked on it. 2 and 11 out of 20 is our answer for this question. 2 and 11/20ths. We've dealt with our whole numbers. We've dealt with our fractions. Put them together. That's our answer. Saying that, here's the final thing you have to do today, and then you can stop listening to me drone on. That's why I timestamp the videos, by the way, so you don't have to do these all in one go. You can jump back and forth to the bits that are relevant to what you need at the time. They say, what is 4 and 4/5 minus 2 and 3/7? Have a go at this, see what you think, and I'll be with you in just a second to explain how to do it yourself. Okay, so 4 minus 2 is where we're going to be starting. 4 minus 2 is equal to 2. Then 4/5 minus 3/7. Okay, so 5 7s is 35. So we're going to end up with 2 fractions out of 35. Then 4 sevens multiplied together is 28. And 3 fives multiplied together is 15. 28 take away 15 is 13. So we're going to have 13 out of 35. We can't do anything with this because it doesn't simplify anymore. So our answer is 2 and 13 out of 35. Make sure you don't forget the 2 part. Very good job if you managed to get 2 and 13 out of 35. This does throw a lot of people off. So all you can really do is go back through the video, look up resources online on your own, see what you can get. Hopefully, as you do more of them, you sort of go, okay, I understand why a mixed number is the way that it is and a top-heavy number is the way that it is. And just know that those can be added to other fractions. They can be added to decimals or percentages, or they could do addition, subtraction, comparing, ordering, all of these different things. But the methods are the same, whether it's a mixed number or a top-heavy fraction. One final thing I should probably show you how to do is how to get back from a mixed number to a top-heavy fraction, because you might be asked to do so. So I've just thought of this. Let me show you how we get back. Let's say we have 3 3/4, okay? And we want to get back to a top-heavy fraction because it may be useful to do this. 3 3/4, how do I get it back to a top-heavy fraction? Well, we know that the bottom number of the mixed number will be the same as the bottom number of our top-heavy fraction. So that's going to be the same. So we can start by saying it's going to be out of 4. Here I'm going to do 5 and an eighth, and I'll show you the same thing. Okay. Here we know the bottom number is going to be out of 8 because the bottom number is the same in both. Then what we do is we do 3 times 4, so the whole number times the bottom. So 3 times 4. And then we're going to add the top number. So 3 times 4 is 12, add 3 is 15. So we end up with 15 out of 4. What do you think this one will be then? Well, 5 eighths is 40, and then we add 1. So 5 times 8, I'm only putting them in brackets to really show you that we do this bit first, add 1 is going to be 41. So our answer is 41 out of 8 and 15 out of 4 respectively. So that's how we get back from one to the other. So to get from here to here, we do how many 4s and 15 is 3. How many left over? 3. So it's 3 and 3. How to get back from here, we do 3 times by 4 equals 12. Yep. And then we take this down from here and we add it on. So 12 add 3. Okay. Do the same on the second one just to show you the method. So 5 times 8 equals 40. Add, bring the 1 down, equals 41. Like that. And it's going to be out of the same bottom number that it was before because it hasn't changed. So it's still 4s, it's still 8s. And that's our answer. So that is everything you possibly need to know at level 2 about fractions. These are quite a lot of topics. For example, my spreadsheet is 28 slides long, which it never is. Or my slideshow, I should say. But yes, this is fractions. Decimals, a little bit less long. Percentages, a little bit less long. Fractions is the big one. And so getting to grips with how to work with fractions is a lot of marks in the paper that you can use to help you progress and pass the level 2. So thanks for watching. If you have any questions, leave them in the comments section below, of course. I'll get to you as soon as I can. And hopefully this is valuable. See you next time.